Okay, good morning. Let's get started for today. And so we're going to do another example in chapter 5, which is example 5.7. So we'll do example 5.7 for today, and that'll be due next Tuesday. Okay, so you can open up the example 5.7 document, and then also the flight scheduling Excel file. Okay, so this exercise, we're going to do another network model, and this is going to be an interconnected network of flights, and so we're going to look at how we can do a best model for flight scheduling using network models and network diagrams. So there's an option over there here. If you after the class, you can look at it, and it shows a little information on how flights actually, or how airlines actually schedule flights. It's kind of interesting. It goes along with the topic. So take a look at that when you get a chance. Let me read the description for today's exercise. Okay, so I think this is the same one, example 5.8 in the older version, but this is scheduling flights at Tri-City Airlines. So the Tri-City Airlines flies several daily commuter flights to and from New York City, D.C., and Boston. The company has been flying a fixed daily schedule of flights, but it's now deciding whether to change the schedule. Each potential flight has an estimated net revenue based on the typical number of passengers for the flight, and we'll see that in the figure and in the spreadsheet. Company owns 4 airlines and it does not anticipate buying any more, so we're stuck with 4 airlines. There's a fixed cost of $1,500 per plane per day that flies any flights. However, a plane that is not used does not incur this fixed cost. We assume that there's no delay time for simplicity, but that's obviously not the case because we're basically assuming that when the plane lands, it can immediately take off. Even though there's a 30-minute lag time for crew changes and safety checks, stuff like that, but let's assume that's not the case here for simplicity. And so it's going to be a military time, and any plane that arrives in the city after its last flight of the day has 2 options. It can either stay there or at a cost of $500, it could be flown with no passengers to different cities to be ready to fly the next morning. So there's two options after the day is done. And our objective is for the company to maximize net revenue per day, which is the net revenue from flights minus any cost for flying the plane, any overnight costs. And so we're going to try to maximize revenue through the schedule or maximize profit, net revenue, which is revenue minus cost. Okay, so let's look at this example and go back to the spreadsheet. Okay, so let's first set up the model and define our inputs, decision variables, objectives, and constraints, and then we'll do the range names in this list in a minute. But let's first just go to the model and set it up like we normally do. Okay, this little range here, these are inputs. The company owns 4 planes. This is in hundreds, so it's $1,500 to fly the fixed cost per plane, to fly the plane per day, and the overnight cost is $500. So these are inputs. Okay, also all of the flight schedules and the revenues that go along with it, with the time and the revenue, this is all a group of inputs, because this will determine the revenues, the scheduling schedule for our flights. So you can highlight this whole area, light blue for inputs, which is B10. B10 to F32, that's a whole block of inputs that lists all the options for the flights, the times, and the revenues that go along with it. So light blue for that area. So right over here, just see what these flights in military time. This would say, for example, this flight leaves Boston, goes to New York. It leaves at 8, gets there at 9 a.m., and the revenue is $2,500. So that's what all these lists show: the schedule and the revenue if we choose to do that flight. So we're limited to send. So we're going to put ones here when we get to it, because this is we can obviously only send one flight per route. So only one plane can fly the route at a time. You don't want to risk any safety concerns that sending 2 flights in the same pack. So the flight flow is going to be less than or equal to 1. Either we choose the flight or we don't with one plane. So this whole area is going to be a big decision variable range, starting in D37. Okay, so solver's going to choose the flight flow, so go ahead and highlight D37 to D59, light red for a decision variable range. Okay, we have a couple more areas to choose from, or a couple more decision variable ranges. And the next one is the ground flow, so there's no cost, but we have to account for the plane. So either we're going to leave the plane on the ground, or we'll send it somewhere else, but we have to know what we do with it. So the ground flow area, this whole block, is another decision variable range, so you can color starting in D63. Okay, so the ground flow is D63 to D134, so highlight that area, the light red color, for another big decision variable range. Okay, we are also going to choose the overnight flow, so either we leave the plane on the ground overnight, or we send it to a different city to be ready to fly the next morning. So this area, another decision variable range. E38 to E146. So basically, you see in all these network models, all the flows are decision variables, and so that's the case here. So we're choosing the flight flow, the ground flow, or where to put the plane for the next 30 minutes, and then what to do overnight. Okay, then we are going to maximize net profit when we get to that. So this is the objective. B156, so you can highlight that, highlight yellow color for the objective. Alright, so we're going to make ranges in a minute, but just see, these are the inputs. So we're going to choose flight flow, ground flow, and overnight flows, trying to maximize net profit. And we've got a number of constraints. We can't use more than four planes. We can't send more than one plane on the same flight, and we have a constraint over here. Okay, remember, we always have this constraint in the network diagrams where the net outflow has to equal the required, and so this is another constraint because we have to account for where the plane goes. So we got the model set up. Okay. Next step is to make all these range names that we see in this list. So there's a bunch of ranges that it'll expedite the process when we're doing the formulas. So let's make these range names here. Okay, so we're going to need a range name for flight origin, flight destination, flight net revenue, and flight flow. So you can select all of it together, and then we'll make 4 range names. So select A36 to D59, and then let's do our range names. So formulas. And create some selection and see how it has 2 options because it doesn't know what you want to choose. So obviously you want it to be the top row because you want it to be flight origin, flight destination, flight net revenue. and flight flow. So unclick this one and just leave it as top row and then hit OK to make those 4 range names. Alright, let's make a range name for net outflow. Okay, so select the I-36 to I-111. Alright, and then make a range name for that. Let's make a range name for ground origin and ground destination. So select these ones here. Okay, A62 to A62 to B134, and then let's make those 2 range names. And again, leave it as top row because you want those names to be the ranges down below the columns. So unclick the left column here and leave it as top row and hit OK. All right, let's make a range name for ground flow. Okay, so select D62 to D134 and make a range name for that. Okay, we also need a range name for overnight origin and overnight destination. So go ahead and select A137 to B146 and make those 2 range names. Alright, again, change it to only top row, uncheck left column, so top row. And OK. Let's make a range name for overnight flow, which is E137 to E146. Okay, then we need a few more. So we need number used and number owned, so just this one. B149 to B150, make a range name for that. Number owned, so D149 to D150, and make a range name for that. Okay, and I think the last one is net profit. So select A156 to B156 and make another range name. Alright, let me pull up the name manager and let's go through these and make sure that we got all the appropriate range names. So you can double check by clicking on the name manager. Yeah, so we got flight destination, flight flow, flight net revenue, flight origin, ground destination, ground flow, ground origin, net outflow, net profit, number owned, number used, overnight destination, overnight flow, and then overnight origin. Alright, so double check all those range names, and if anyone needs any of those repeated, then let me know, because it's a big spreadsheet, so we'll need to call for the ranges to do the formulas. So everyone got the range names? Alright. Great. Let's move on to step one, I guess. Alright. So we have to put in this really big formula into column I-37 and apply it down to satisfy the flow balance constraint. So let's go to I-37 and hopefully you have your Word document to look at, because you're going to type in this big formula exactly because it's going to satisfy the flow constraint. So let's go to I-37 and type in this formula. So in I-37, right, so here's net outflow, and the first one is the Boston 8 o'clock. So right here, I-37, start typing in that formula that you see in step one. So it's a big sum F formula, so here we go. Alright, so here we go. Let me see if I can run through this, and then I'll explain what it means, but make sure it's the same one that's on your printout. So equals SUMIF flight origin H37 flight flow plus SUMIF ground origin H37 ground flow plus SUMIF overnight origin H37 overnight flow there we go. We can see it better that way. So let me run through it again. Equals SUMIF flight origin H37 flight flow plus SUMIF ground origin H37 ground flow plus SUMIF overnight origin H37 overnight flow. And then here, after the parentheses, we have minus. And in this parenthesis, we have SUMIF flight origin H37 flight flow plus SUMIF ground origin H37 ground flow plus SUMIF overnight origin H37 overnight flow. And then the second parenthesis to close the argument. So what this is doing is taking all the flights from Boston at 8 o'clock that come out of the origin and go into the destination and accounting for everything. So this takes care of the flight flows, the ground flows, the overnight flows, and then all the destinations. So this is going to guarantee that we account for all the planes after this model is solved. So double check this, and again, you have to have this formula 100% correct because we're going to apply it down the column and for all the other flights. Alright, so there's the formula again, so I double check that one. You should get a 0 for now, but getting the formula correct is the most important thing. Alright, so hopefully we got the formula, so if you hit enter. Alright, so assuming you got that formula correct, you're going to apply it down all the columns, or all the flight options. So if you got that formula, grab the bottom right corner of I-37 and drag it all the way down to the other options, like this. Okay, so see we got that same formula, but it goes to the appropriate flight time and flight. See how this is Boston 9.5. And you should have the formula all the way down, and this one should be the one for DC, military time of 20. Okay, So we got that. We can go to the next step. All right. So everyone's got that the big formula applied all applied options here. Okay. The next step is step 2. This one's easy. So just put a 0 in K37 and copy it down to K column.
Sorry, Professor. I got the name of it. I don't know where.
Oh, for the net outflow?
Yeah.
Okay. I can look at it if you post it. I can check.
Okay, I will post it.
Yeah, so posted in 5.7, and I'll take a look at it. And just to finish this step, so all we're doing here is we're putting zeros in as required because the net outflows have to be 0, so the plane can't be in the air after the model is solved, basically. So put zeros over here in the K37 to K111. So K37 to K111, just type in a 0. So when you run the solver, the net outflow has to be 0. So there you go. All the required, just put in a 0. Yeah, it looks like the formula's right. So let me see what's going on here. It could be that the range names are. So here's one of the issues. So one of the problems, or one problem so far is the flight flow was not the right range name. So if you just select this area and D36 to D59 and rename it, like just select that and do create some selection, top column okay, and then it should redefine the range name to the correct area.
Do we delete first?
No, it should just replace it. But you can double when you give a name manager, it should be. So it should be D37 to D59.
Yeah, I changed it, but still name.
Let's check the other. So how about flight origin? That's good. That's good. So those ones look okay. Let's try the other ones at the bottom. So see, this one, something's wrong with the ground destination one because it's not doing anything. So let's look at that one. So ground destination. Oh, it's just here. All right. So the only issue, or the other issue, was that you just didn't type the name right. So right here, for ground destination, it was spelled wrong. So just change the spelling, and it should work.
Got it.
And then yeah, just copy it down. Okay. Okay, so back to the solving the model here. So we did step 2. All right, step 2, we'll just put a 0 in K37 and copy it down to K column. So you got zeros on the right side of the constraint here. Okay, so you just type the 0 for all the required. The next step let's put a 1 in F37 and copy it down the F column. Okay, so put a 1 there, and this is just to clarify that you can only send one plane per flight, right? You don't want to be two planes in the same flight. So at max, your flight capacity is 1 if you choose to do the flight. So just put a 1 in all of these flight capacity options. Okay, so in F37 to F59, just put a 1, okay, to show that you can't send more than one flight per flight flow. Step 4, let's put this formula in B150, so back to the spreadsheet. Okay, so B150, the formula is equals okay, so you just have to account for the planes. So all the planes have to be in the overnight flow area somewhere. So the number used in the overnight flow can't exceed the total number of planes we have, which is 4. So right here, the number used is equals sum overnight flow. Step 5 is to put these formulas in B153, B154, and B155. All right, and so we'll start with B153. Okay, so let's calculate all the monetary values, starting with B153, which is this formula equals. Okay, so equals sum product, flight net revenue, comma flight flow. And the revenue we get from the flights is if we choose the flight, we get the revenue, and if we don't, we don't. So this is the sum of all the flights, the sum of all the revenues we get from the flights that we choose. And the ones that are 0, then it just doesn't add those. So equals sum product, flight net revenue, flight flow. So that's the sum of all the daily revenues from the flights that we choose to choose. And B154 equals sum product. Okay, equals sum product C138 to C146, comma, overnight flow. Alright, and so this just says that the fixed cost per plane is so if you choose to, what is this? this is just going to add the fixed cost per plane. So we're going to add the fixed cost of 1,500 or whatever it was for each plane. All right. So sum product C138 to C146, comma overnight flow, and for the overnight cost, then B155 equals sum product D equals sum product D138 to D146, comma overnight flow. So this means this adds up. If we choose to send the plane to another destination overnight, so we got to pay the extra cost of $500. So sum product D138 to D146, comma overnight flow. Okay, and let's calculate our objective, which is net revenue. So this is basically just revenue minus cost. So go to cell the objective cell, which is B156, and type in this simple formula. All right, so net profit is B153 equals B153 minus B154 minus B155. So it's revenue minus both costs, and the net is the net revenue or the profit. Okay? So revenue minus costs, B153 minus B154 minus B155. All right, everybody good so far? And with this model, okay, next step 7. Let's make a reference to the flight net revenues in C1 and cell C37 and copy it down to C column. Let me see. So let's go to C37. Okay, so what we're going to do here is link in the revenues from the input table into the flight net revenues, and then if we choose the flight flow, we get the revenue from it. So in C37 equals F10 and then just drag that formula down because that's going to apply to different revenues for each flight. And it's going to take what comes from the table and put it into the flight net revenue. So if this is equal to F10, just grab the bottom right corner and drag it down the column like this. And what you've done, hopefully, is take the revenues from each flight, which are listed in order, and the revenues are now linked down here in the flight net revenue. Okay, and while we're here, we need to put values into the flight flow. So just go ahead and put zeros in for now, and Solver's going to figure it out in a little bit. So in D37, we need values into our decision variable for Solver to change. So I'll just put a 0 in for now. Okay, so in the flight flow area, you can just put in zeros for now, and then Solver's going to solve, if we choose the flow, then we get the revenue. If we don't, then it just stays a 0. Okay, step 8. Let's put 0 for the ground cost in cell C63 and copy it down to C column. Okay. So the ground cost is 0, but we have to account for the plane. So even though all these are 0, this goes into the network because we have to know where the plane is. So for example, if the plane lands at 8 o'clock and we want it to take off at 8:30, we have to show that we just kept the plane on the ground for 30 minutes. So all the ground flows will help determine where the plane is when we need it to take off. So ground cost is 0. So put a 0 in C63 and just copy it down for all the ground costs. They're all 0. Okay, so C63 to C134, put a 0 in there. Alright, and we also need to put values into the ground flow because this needs to be switched by Solver. So let's put zeros in the ground flow for now. 0 here. So there you go. In D53, put D134, put zeros in there. Alright, so we got a few more things before we solve this. Step 9, let's put equals $$D, $5 in cell 138 and put that in for the fixed cost. So go to C138 right there, which is, and this is equals. And it just equals $$B, $5 because the fixed cost of flying any plane per day is $1,500, right? Alright, so just equals $$B, $5 there. And you can just grab the bottom right corner and apply that fixed cost for all the other options under the fixed cost column. And so you got 15s in there for a fixed cost of $1,500 per plane per day. Okay, step 10. Let's put a 0 or a 5 for the appropriate overnight cost in D38 to D145, D146, and let's put a 4 in D150. Okay, so we need to note if there is an overnight cost, then what is it? So what we're doing here in the overnight cost is if the option is to keep the plane on the ground, then there's no cost. So Boston to Boston is a 0. But if you choose to send the plane from Boston to New York overnight, then that's a cost of 500. We'll put a 5 in there. Alright, so you see if we choose to send the flight overnight from Boston to DC, that's $500 as well. Okay. Obviously, if we send the plane from New York to Boston, that's $500. But if we keep the plane on the ground in New York from 20 military time to 8 in the morning, no cost, leaving it in New York overnight. But anytime we send it somewhere else, New York to DC, that's $500. DC to Boston overnight, $500. DC to New York, that would cost $500. However, if we left the plane overnight in DC until 8 in the morning, no cost for that. Okay, so the planes that stay on the ground overnight, no cost, and the planes that fly somewhere else to be ready in the morning, that's $500 to prepare for the next day's flight. Okay, let's put zeros in the overnight flow here, and Solver's going to figure that out as well. So in E138, okay, E138 to E146, put in zeros for the overnight flow. All right, and the last thing here is we have 4 planes, and so we can't use more than we have. So just put a 4 in D150 to note that we have a maximum amount of 4 planes to use. We're gonna use them all, but just to determine that we can't send more than 4 flights in the air at the same time. So the next step is to run Solver and determine the optimal flight schedule, which is going to maximize net revenue. All right. Everyone good on the spreadsheet before we run the Solver? Okay, well, I guess we'll find out after we run the Solver, right? Yeah, let's do that. All right, so let's solve this, or try to solve it. So data and Solver. All right, so the objective is the net profit cell. So hit the button and choose D156. Okay, we're maximizing that. Let's see. So I think it might be easier just because we have this huge range. Let's just type in the range names for our flows, and then hopefully that works. So we're going to type in the 3 range names identical to the to how they were defined. So by changing variable cells, you can type in okay, so type in those three range names exactly with the comma. So it's flight flow, or flight underscore flow, comma ground underscore flow, comma overnight underscore flow. And they got to be so exactly correct because that'll note that they're the range name that you defined. All right, and we have some constraints. So subject to the constraints, click on Add. Okay. The first constraint is the flight flow has to be less than or equal to the flight capacity. We can just, so the cell reference is flight flow. Okay, so you can just specify it like that. So flight underscore flow, less than or equal to constraint of 1. So flight, assuming you have the range names defined, flight underscore flow, less than or equal to 1. Okay, so hopefully this is working so far with the correctly spelled range names. We have two more constraints. We got one right here, so let's just do that one. So number used is less than or equal to number owned. And these ones, it's just one space, so I'm just going to select it. So cell reference, B150, less than or equal to constraint, D150. All right. So D150 less than or equal to D150, is it okay? And that should give you number used is less than or equal to number owned. And we have the other, the flow bounds constraint. All right, so this one I think again is easier just to type in the name and specify manually. So cell reference is net underscore outflow, and just set that equal to 0. Okay, so specify it just like I did, net underscore outflow equals 0. All right, and I think that's it for this. Make sure this is changed to the simplex LP, and let's run through the options, and then if we need some redefining, we can do that. Objective is net profit. Maximize that. You're changing flight flow, ground flow, overnight flow, and flight flow is less than or equal to 1. Net outflow equals 0. Number used is less than or equal to number owned. This is checked, and this is simplex. Okay, so do we need steps repeated for the solver parameters? All right, well, let's solve it and see what happens. And if you get a solution, hit OK. I think that's what we're supposed to do.
I got it though.
Okay. Yeah, the correct solution is, well, this is in hundreds, so it should be, 39, what is it, 39,600, I guess. But we got 0 here. Okay, so I can look at some of the ones that didn't get 0, because this is a big model, so there's sorry. There's good potential for error in all this calculations, but did some people get 396? All right, there's one. Okay, so let me run through the solution that we. Oh yeah, go Dominic. All right, so let me run through what the solution is, and then I'll look at the ones that did not get the solution to see if I can fix them. All right, so the flights that we chose to send planes on, there's ones, and the ones we didn't, there's zeros. Okay, and we didn't send more than one plane per flight. All right, all the net outflows are 0. And we accounted for the planes on the ground to have them ready for whenever we need them for the plane. And you can see down here that we did not send any planes overnight. It must have been too costly, so we kept 2 planes in Boston overnight and the other 2 planes in DC overnight. We used all 4 planes, and yeah, and then also the last question. How many flights were flown? Alright, so how many flights were flown to give us a profit of 39,600? So if you go up to here, so the number of flights chosen in the flight flow, the total here is the number of flights we chose to do per day. And you can count them if you want, or the easiest thing to do is just go to D60 and type in equals. Equals sum. Okay, equals sum flight flow. So that'll tell you the total number of flights we're choosing to fly per day. So just equals sum flight flow to see how many flights we chose. And right, so hopefully you got that we have 17 flights flown. All right, it seems like a lot, so 4 planes, but I guess we're able to do that. So yeah, that worked, and we sent 17 flights. Okay, so let me look at some of the spreadsheets that got 0. So if you got 17 flights and the net profit of 396, then you're done with this one. So that concludes example 5.7. So you can, whenever you're done with this, you can post that under example 5.7 is discussion forum by next Tuesday. Alright, so that goes there, and then make sure, example 5.5 and 5.6 from Tuesday, and example 5.7 from today, both due, by next Tuesday. Okay, so get those in, and, so if some people need, help with this one we just did, example 5.7, we can post those and I can look at those right now. But if you're done with this one, then you're done. So if you're done with example 5.7, you can post it, and that's it for today. And have a good weekend. But Jessica, do you want to post yours and I'll look at it? And if anyone else needs to look at theirs, I will try to troubleshoot the problem here. But if you're done with it, then that's it for today, and thank you.
Thank you, Professor. Have a great one.
Okay, so this is yours. Yeah. Okay, so it looks like the solver's right. Let's see. Net profit, max,
And I think like if you run it through yours, they'll do it.
No, and so that wasn't, so the solver's good, but that didn't fix it, so there must be something else. That was good. That's good. There might be, I don't know what all these ones are doing here, so this might be, yeah, this might be the problem. Let's see. Maybe this. Okay. So I fixed it. There's one slight error in this calculation. So if you change the one in I-37, you need to subtract everything that goes out of the destination. So see, yours had, Jessica, yours had a minus sign here, but it didn't minus everything. It just minus the one from there. So put a parenthesis here, and then put another parenthesis there. So this whole block has to be all subtracted, not just the first. So put a parenthesis right there, and another one right there, and then apply the formula down, and that should work. You see what I'm saying? Or you see what I'm... Yeah, so it's like sum of flight origin H37 flight flow plus sum of ground origin H37 ground flow plus sum of overnight origin H37 overnight flow, then minus parentheses all the rest of it. Okay, so see how all of that there is in parentheses and subtracted?
Right in front of the sun,
Yeah. So if you make that change, and then apply the formula down to the other net outflows, and then move on the solver, then I got it to work.
So once I do the formula for the I-37, just bring it down again?
Yeah, exactly. Okay, so once you fix this one, just grab the bottom right corner and drag it down, alright, to overwrite the other ones. And then if that works, you can run the solver again and see if you get the right solution.
Okay, I got it. Thank you so much.
Okay, you're welcome. Okay, so anyone else need to look at their spreadsheet?
Yeah, Professor. I sent my name,
Okay.
but I fixed it watching you help Jessica. So you can kind of like forget about mine.
Oh, so you're good? Okay.
Yeah. Thank you.
Alright, sure. Yeah. Okay, so I'm still looking. I haven't seen anything wrong yet, but there's got to be something because you're getting zero. So
What was the cost of the name manager?
sorry.
Maybe the wait, let me check. I'm not sure. Like I thought it might be some problem with the name manager, like the
Oh yeah,
name manager.
I'm looking, but it looks like you got the range names
Yeah.
correct. Usually the problem is with this formula, but it looks good. Let's see. Well,
Perhaps something gone wrong at the beginning of this project, like the
well,
manager.
yeah, the name. Let's look at that.
Yeah, because I missed some steps at the beginning.
Okay, let's see. Maybe that's. Well, here we go. Maybe this. So ground origin. Yeah, maybe this one needs to be redefined. Let's try that. That might have been it. Let's see.
Yes. I think the ground origin might be the problem. Yeah, I try to redefine every
Yeah, that's what I just did. So let's try.
Yeah.
Did it work?
Yeah, it worked. After I retry all the name manager, I think it might be something. Maybe I just select everything while trying to complete
Oh
the
yeah.
name
Okay.
manager.
So yeah, the problem was that the ground origin was not the right range, and so that was it. It was this one.
Oh.
And so
Okay.
all I did was redefine the ground origin to be the correct range, and then it should work. So it worked, right?
Yeah, it worked. Yeah.
Okay.
Okay, thank you.
You're welcome.
Okay, I'll repost it. Thank you. Have a nice day.
You too.